Alright, in this recording I'm going to do 3 examples of finding zeros, both real or complex, of any polynomial. The first step, of course, you would want to do is to write down the possible rational zeros. Another first step that would be very helpful is to graph the function on a graphing calculator. The reason for that is it can show you right away how many real zeros you have and maybe even exactly where they're located. Okay. My possible zeros, remember we write the factors of the constant on the end over the factors of the leading coefficient. In this case it's 1, so it's not going to divide by anything but 1. So my possible zeros are 6, 3, 2, and 1, both positive and negative. But from looking at my graph, now if you didn't have a graph, you would just start going through those numbers until you found a zero that worked. If you do have the graph, we can see that 1 and negative 2 should both be zeros. Now we'll do the synthetic division to make sure. The other reason you want to do synthetic division is because you can see there are 2 real zeros. We have a 4th degree, which means we have a total of 4 zeros, which means we must have 2 imaginary or complex zeros, because they do not show on the graph, because the graph is only for real numbers. So I can see 1 is one of my zeros. I'm going to go ahead and do synthetic division. And the reason, you may ask, well, if you know it's a zero, why do synthetic division? The reason is to break down the polynomial to a smaller degree so that I can eventually use factoring to find, or not factoring, but the quadratic formula to find those missing zeros. So again, synthetic division, drop the first number straight down and then start 1 times 1 is 1, and I write it under the next number and add. And then I multiply. 1 times 3 is 3, and I add. And multiply. 1 times 5 is 5, and I add. And 1 times 6 is 6, and I add to get 0. So yes, 1 was one of my zeros. Up here I'm going to write down my answers as I go. 1 is an answer. Now at this point you do not want to go back up to x to the 4th plus 2x to the 3rd, our original polynomial, and do division with negative 2. You don't want to do that because it's not going to help you out any. What you want to do is notice here, when we divide 1 time, that drops us to a 3rd degree polynomial. And so now I have the polynomial 1x to the 3rd, and these are my coefficients, plus 3x squared, we have positive 5x, and a positive 6. I have this polynomial now. It would be times the factor x minus 1, because I just divided that out. But we want to go from here instead of going back up, because if we divide this one more time and find a 0, then we're down to a squared and can either factor it or use the quadratic formula to find our other zeros. Okay, so I am going to do synthetic division using this polynomial and negative 2. Since I can see on the graph that should be a 0. So we go through and do our synthetic division. Alright, and we can see yes, it was a 0. The more important thing is that now we're down to an x squared. We drop 1 more degree. These are our coefficients. So we have 1x squared, positive 1x, positive 3. Okay, we set that equal to 0 to find our other zeros. It does not factor, so we plug it into the quadratic formula, which again is negative b plus or minus the square root of b squared minus 4ac all over 2a. A is the number in front of x squared, b is the number in front of x, and c is that constant on the end. Alright, so let's go ahead and plug that in. We have negative 1 plus or minus the square root of 1 squared minus 4 times 1 times 3 all over 2 times a, which was 1. We simplify that. We have negative 1 plus or minus the square root of 1 minus 12 all over 2, which gives us negative 1 plus or minus the square root of negative 11 over 2. We can see that we have a complex number here, or an imaginary number, because of the negative root. Simplified, we can't have that negative there, so remember anytime you have a negative root, you write it as I, root 11 in this case, all over 2. So there are my answers. My answers are 1, -2, those are my two real zeros, and then my two imaginary zeros, 1 plus or minus I root 11 over 2. So you can see why it's important to continue doing synthetic division and breaking down that polynomial rather than going back to the beginning. Otherwise, you'll be going, how do I find those imaginary zeros? And this is how you do it. Okay, this is example number 2 out of the 3. So here we go. Again, we want to start by writing down our possible zeros. Plus or minus 5 and plus or minus 1 are the factors here. The factors of my leading coefficient, which is just 1, doesn't make any changes there. So, again, I've graphed the polynomial here, and it's a little small to see, but we have a 0 that's close to positive 1. We have one that's right on -1 and one that's close to -4. Those close to's, you could trace function, but it would give you the decimal, and they want the exact answer with the roots in it. So we are going to start with the 0 that we can see there. We're going to do synthetic division again because it will break down our polynomial to a quadratic or a squared. Okay, so I think it looks like -1 is an exact root, so I'll start with that. If it's not, I'll find out soon here. And I do my synthetic division. And in fact, it is a 0. Okay. Then I write down this was third degree. I divide once. That brings me down 1 degree to a squared. And these are my coefficients. So I have 1x squared, positive 3x, minus 5. And I want to solve that polynomial. If it factors, I would factor it. It does not factor. So again, I plug it into the quadratic formula. A, B, and C. So we have -b or -3 plus or minus the square root of b squared, so 3 squared, minus 4 times a, which was 1, times c, which is -5, all over 2 times a, which again was 1. We want to simplify that. So we have -3 plus or minus the square root of 3 squared is 9. -4 times 1 times -5 is a positive 20, all over 2. And go ahead and add those, and that is as simplified as this one is going to get. There are my other two zeros. So my answer is -1 and then -3 plus or minus the square root of 29 over 2. And our last example. Okay, we can see here that we can write down our possible zeros. The factors of 3. Okay, my constant over the factors of my leading coefficient 4. Okay, so my possibilities, and I can see from my graph that it's probably at 1/2, but I'll go ahead and write down the possibilities anyways. 3 over 4, 3 over 2, and 3 over 1, or 3. And then 1 over 4, 1 over 2. 1/2 is a possibility, that's a good sign. And then 1 over 1, or 1. Here are my possible zeros. And it looks like it's at 1/2. The other thing I can see from graphing it, which is helpful, is that it touches the graph on the x-axis there. Touches on the x-axis instead of crossing, which tells me that 0 of 1/2 has even multiplicity. So if it works once, I'm going to put it in again, because it should work an even number of times. So at least 2 times it should work as a 0. We want to break down the polynomial as much as we can. We want to get it down to a squared so that I can see I must have some imaginary zeros because it only touches the x-axis once, and this is a degree 4, so it should have a total of 4. So we're going to do 1/2. Write down my coefficients. Remember, if you have one with missing parts, like an x squared is missing or an x is missing, don't forget to put a 0 in their place, or that's going to mess up your synthetic division. We go ahead and multiply. And indeed, it is a 0. Now, I could write this polynomial, notice it was 4th degree, now this would be a 3rd degree polynomial, 4x to the 3rd minus 2x squared plus 12x minus 6. But just to save room here, I'm just going to piggyback off of this one, because remember, we want to continue to break it down. We don't want to go back up to the top, or we're not going to get down to our x squared polynomial. We noticed again on the graph that this should have at least multiplicity 2, and even multiplicity since it touched the x-axis instead of crossing. So let's try 1/2 again. And we find that yes, it does work twice. So one of my answers is 1/2 with multiplicity of 2. And now I'm down to an x squared. Okay, this is originally x to the 4th. I divided once and got down to an x to the 3rd. Divide again, I'm down to an x squared. My coefficients are 4x squared plus 0x plus 12. And I want to set that equal to 0 and solve. It doesn't factor. However, I could use the quadratic formula, but since there's no x term, probably the fastest way to solve this would be to just subtract 12 from both sides. Since, again, this is because there's not an x term in the middle, just an x squared. Divide both sides by 4. I'm going to move it up here in case I run out of room. So I get x squared is -3. And then I would take the square root of both sides. Anytime you do the square root and you take the square root to solve, you have to put plus or minus in front. Okay. And last thing to do to simplify this, I can't have a negative root. That's not simplified. So we write it as I root 3. So my answers are 1/2 with multiplicity of 2, and then positive I root 3, and negative I root 3. There are my 4 zeros. 1/2 twice, 1/2, 1/2, positive I root 3, negative I root 3. So hopefully this helped you with the process of solving for the zeros.